Okay, there we go. Okay, this is working group life cycle, node life cycle. So the agenda is in the meeting notes. So I'll share my screen in just a moment. But first, are there any new attendees that would like to introduce themselves and say hello? Okay. All right. Let me share my screen. Let's get started then. Okay, let me see. Oh, good. All right. I didn't need any special permissions. There we go. Okay. I think so. Last time we had a really good discussion from Uber. So I just wanted to thank the team that put that on. I thought it was really great. It was a really good discussion and insight into what they're doing and what they're thinking about and their journey. So I think we've been talking about more, having more companies come and talk about their experience. That would be really awesome to do. Um, I know I'm from NVIDIA and I'm volunteer. We will do, I'll do a discussion at some point from our experience and our side very soon, maybe even as soon as next meeting. But I just have to put together some slides for that presentation. But definitely an open invitation for everyone. It would be great to hear from all the different end users and how they're, what their interest is in this working group and, what they're looking to get out of it. All right, I think we're going to second item, which is going to be eviction request API. So we've got a bunch of comments, I think, from last time that have, so we had a lot of discussion we want to get through. I'm not sure how we want to do this, Philip. Do you want me to read these or do you want to comment on these specifically, or if you have the people who wrote the comment, do you want to speak up? Like with this one, we can start with.
Yeah, I maybe we can just like touch on a couple of things. Like we can make the meeting short today, since I guess it would be better if the folks who wrote the comments would discuss them. So maybe we can wait to some other time or do them asynchronously. So yeah, I have like a couple of side points. So we've had like a good discussion in the CAP over like review Joe has started mainly on the API parts, which like contains a lot of good feedback. So I guess I can try to share the screen and like show the API of the eviction request, and maybe we can talk about like a couple of these points.
Okay.
Okay, can you enable the sharing for me?
Oh, sorry. Okay. How do I do that? Let me see. Hold on.
So if you hover over the picture, there's the three dots. Click on that and
Yeah.
become host.
Make co-host. Okay, gotcha. All right, cool. Thank you. All right, you should have the ability now.
Okay, can you see my screen?
Yep.
Okay. So yeah, I will highlight the API we have here. So as we discussed last time, we have a couple of things which like we try to reuse for like tracking the interceptors and tracking the evictors. Like so we are currently tracking the interceptors like in the annotations of the pod, and we had discussion that it would be better to track them like single-handedly in the API for like a better validation and tracking. So like we brought this to Signode, and like they did not like fully agree to the API, but they said like they would be willing to experiment with that in the pod API. So I will like make it like a high-level API and as part of the pod. And to reiterate, we have the interceptor here, but this is parsed from the annotation. So we have like the interceptor class the priority and role. And there is like some like couple of validations about like the priorities that can be like used, and about like reserving some like a list of or interval of priorities, for example, for the original controller. And so I would like to propose this like as the main API in the pod. And Joe also had a good point that we are using the finalizers for the evictor. So for example, when you have the component that wants to drain the node, so in our case it could be the node maintenance or a cluster autoscaler, then we are tracking it in as a finalizer. This like as a benefit of that it blocks the deletion or of the eviction request, but it also has its limitations, and we are overusing the construct for the tracking. So I think it makes more sense to put it as part of the API as well. So I think it should be part of the eviction request spec, that we will also track the evictors, which can like dynamically be added and removed during the lifetime of the eviction request. So for example, like there you could have like a 2 or 3 components like not fighting, but like have an interest in removing a pod, and so they can like track like this interest here. And if some of them like does not have the interest anymore, they can remove it. And I guess we can also experiment with the validation of like if the like we could have like a validation when the eviction request can be deleted, also when it is part of the API and not just the finalizer, or we could just leave it like on the finalizers and expect like the components to also add the finalizer. Okay, so these were the most 2 things I wanted to discuss, which I would like to like present as an to change in the API. And yeah, and then I remember in the review there is like a couple of points that we are worried about, like the complexity of the interceptor. So if you have like a multiple interceptors and they can like preempt each other. And then we also had the topic about interceptors, how to actually evict the interceptors. So like if we guard the interceptors with other interceptors, we could like achieve a deadlock. But like from my point of view, it's like we don't have if we don't have like we do not have a guarantee where the interceptor will live. So it could be even outside the cluster or like in the management cluster. And yeah, I don't know if like if we should get like into business of like tracking like the interceptors or the health of the interceptors. So the API itself should like serve as the health check of the interceptor if it is responding or not. But I feel like it's better to leave the responsibility of like the availability of the interceptor on the interceptor, which has some problems, which also Ryan has discussed. So I don't know if you want to also give your perspective on this.
Yeah, sure. I think yeah, I was pointing out the like the challenges of when you have an interceptor and it sort of has I think the word I was this phrase I use is that it has state, and then it's conducting a process where it's going to be deleting a pod or doing something with the application. Maybe it's not even just deleting the pod, it's maybe preparing to delete the pod, and those steps might be stateful. And so there's a challenge, and like when we go through and um, try and execute those steps, and perhaps they get halfway done, or they don't complete for whatever reason, and and we move on to the next interceptor, and what would happen to the application? Could we possibly cause damage? Could we be worse off? Um, in that scenario. So that's my fear, is like that these interceptors are it's very opaque, like what they're doing, and they could absolutely have state, and just like the application itself. And so our like defense, I think that we were talking about in the in the design, was like we can use some sort of heartbeat or deadline or um yeah, but my concern is that, like, is that enough? Like, what does it mean? Is that going to be enough for like, what does that defend against? It sort of, I guess, what it defends against is like the us eventually not reaching consistency, which is like, we want to eventually move the application. Um, but then, like, the question is, like, at what harm? Like, what could we possibly do? What could the interceptor end up doing wrong in the process that could cause harm to the application if that's our only defense?
Yeah, so yeah, like the main defense from our side is like the heartbeat. So we changed it like from the progress deadline seconds. So it's called now heartbeat deadline seconds, which has like gives like more meaning to what we are doing there. And yeah, so this was also one of the things like Lucy wanted to discuss how like what should be the value of the heartbeat. And I think if like we have if we agree to a reasonable value, then this should allow like the interceptors to be disrupted like in some capacity. Yeah, I will give over to Daniel.
Hi. I'm wondering if you have an example when an interceptor might have like critical state that it can't, I don't know, ignore or do something to itself.
So it could be um like I was thinking even in like the KubeVirt case where we're probably going to do VM migration, and the VM might be, I don't know, partially done with its migration, and we time out here and move on and just delete the pod. So that's what I mean. Is like we don't really know what the interceptor is doing, and that can be some sort of operation like VM migration, for example.
I see. Um, so the problem you were describing was not about the interceptor like evicting itself, but it's more like what happens if the interceptor doesn't respond.
Yeah, I think so. I would look at them as I'm thinking about two separate problems with interceptors, and interceptor eviction is definitely a challenge. And the life cycle of the interceptor is a challenge, and then what the interceptor does. What the point I want to make is that I think what the interceptor does, the operations, they can be stateful. And so like their defense here, I think what we're saying is that it's a heartbeat, it's a timeout essentially, because we need to move on, right? I think that's like the big requirement, is that we want to move on. Like that's the difference between what we're proposing here and like what currently exists, is that we have to move on. Um, but I'm just pointing out that there's that challenge, right? Is that the trade-off is that there could be state there. So like what I was asking is, how can we think about this in such a way that we can handle cases where that interceptor could have some state?
I see.
Yeah, if I can. So I feel like this is like a different different domain that we do not probably want to solve, because I totally like agree there is like this problem, like that as an application you need to like care about the consistency. But even today, like when you have, for example, are doing the VM migration or some other like sensitive work, like you still have to expect like the disruptions of your application. And the main problem is like there is like different ways how you can run your interceptor, and So for example, you could have like a HA or high availability and have a like leader election, or like as I said, it might not be even running in the cluster. And yes, so yes, so I'm not sure like if how we should actually approach this, like to be actually useful in some regard. So I feel like we should leave this like on the users to solve this for themselves.
Yeah, I think so where like kind of where I was going with some of the questions, and so to bring back in the interceptor lifecycle, because I think that the interceptor lifecycle part and interceptors for interceptors, and then this I think like the some of these requirements um come into play when we look at the interceptor as like a regular controller. And that was one of my comments, is that what I was suggesting to take a look at, like the kubelet, for example. I think the kubelet technically functions as an interceptor, right? I think we can probably agree that it does, and it's kind of interesting to think about, and that's kind of what I wanted to see, like what happens if we were to take the idea of an interceptor and model it to be like the kubelet, like how do our requirements change? How does our design change? Like what happens? So one of the suggestions I made is like, well, um, what if you ran this as a daemon set, right? Like what if you ran the interceptor as a daemon just for the in-cluster ones, right? You mentioned the out-of-cluster ones, but just the in-cluster ones, they were run as daemon sets. Now what changes, like in the design, now things are node local, right? Like there's no assumption about like when you have the daemon sets locally, they're tied to the node lifecycle. You could probably even have them accessible by the kubelet. You can make them part of like the node drain workflow. Um, and then there's also this question about like the timeout too. You should be able to detect health, right? When something is running as a daemon set locally, we could find the pod. Um, so that's what I was thinking about, like when I was going through these questions, like there could be another way to look at this, instead of looking at this as a controller, interceptor as a controller, and then how it might change the design. Just wondering if you thought about that at all. Yeah, Daniel, go ahead.
I think it makes sense in a way that the current implementation or the current API would allow everyone to decide how they want to run it. Like if it's a normal controller or a daemon set doesn't really matter here, right? It always depends on how you're able to intercept the thing. And if you have state, you might want to, I don't know, save it somewhere in an object or somewhere else. But for the general thing, it doesn't really matter. I'm wondering if we are talking about continuing in any case, is there a way to stop the whole process from an interceptor point of view? Like if we are not able to move the data of our database to a new node, we probably shouldn't evict the thing.
Yeah, so like there is like currently there is no way to like push back and like from like the interceptor itself can only like show, as you can see in the status, you have the cancellation policy, so you can only like advertise if you can be terminated or not, or I mean if the eviction request can be cancelled or not. But I mean the control is from the point of view of the eviction like requester, because even like if you cancel it, but I guess because even if you cancel it, like the requester can create it again. But I guess we could like implement such for example, some like pushback like number that can suggest like to controller that something is wrong, and that there is like if it's possible, like we should be like this eviction request should be cancelled. Yeah, I'm not sure what to do exactly here yet.
Yeah, I think it doesn't need to be necessarily cancelled. I think pushing back would be fine, but at least letting an interceptor stop the whole flow for now. Like maybe, I don't know, some kind of retry mechanism, because we know it's not going to work right now. And if we would continue, we might cause an incident or something like this.
Yeah, so like one of the things is like if you are interceptor and you like have an HA or are able to make sure you are running, you can like block the eviction indefinitely. Like if you still like keep pushing the updates. So that's actually like a valid state, I think. And I suppose like the controller or like the eviction requester like should acknowledge if it has like a couple of eviction requests that are unable to be removed. Like if it's like freed some capacity and it is like successful in that, it might cancel the eviction request by itself. But if you are, for example, draining the node, then like it's probably not like able to, like it has to remove all the pods.
Interesting. It's cool that there's a way. I'm wondering if this would hide problems. Like if one of the things can't be evicted for a long time.
Yeah, so there is not like exactly like like programmatic way to push back. So like you can use the eviction request to actually like fill in the message or the conditions and basically report like what's wrong. And so like a human observer could take a look and see what's wrong and then decide to act accordingly. But we don't have like a programmatic way of pushing back. And also when we don't have an interceptor, we are also like trying to use the classic like imperative eviction API, and we have this failed API eviction counter that we try from time to time to evict during using the normal eviction API, and if we fail, increase the counter. So I don't know, like I don't know like what should be the use case of like having the programmatic approach. How we could like use that. Yeah, I guess like if we desire such approach, I guess we can implement it in the future. It's just adding like a specific field and specific contract that should be used by some, for example, drainer component. And then like this was also one of the things I think Lucy wanted to discuss, how we can actually implement some better communication like between the interceptors and like the evictors. So this is for sure like a point that we could improve.
Yeah, that makes sense to me. I mean, we have internally some system that's quite similar to this. So I was thinking about our use cases and what we often see. And this is how this came up to me, because yeah, the last thing we want to do is causing incidents by removing pods that are still hosting data and shouldn't be evicted right now. But it's a good point that we can also work on this in the future.
Yeah, I mean, if you own all the components which are doing the drain and like the interceptors, you can like set up your own API and pass it through like the conditions to set like the reason of the condition that you are able to parse it in some other component, so it can be used like that. But yeah, like for like a like public API that can be used by anybody, we would need like a good use cases on all like sides to actually have something that's like we can like put a contract to.
Makes sense.
If I may, I wanted to revisit the discussion about like the daemon set thing. So maybe it's a question like if what would happen if like we had like if you required, let's say, an interceptor to register with a kubelet? Like, can we do something like that?
I mean, like a kubelet is like a very special component in Kubernetes. So, currently the best thing you can do is like run a static pod on the node, or like as you said, a daemon set. And I think like even today, for example, you have some daemon sets for like storage or networking that are running on nodes and are able to it's usually sufficient like if you set like a high priority for your workload, like for I think it's a node critical priority, then usually you should be like evicted last, and I suspect like most of the solutions will still like they will still uphold like to these priorities. So I mean, like, are you looking for like some other special use case for like catching the interception even like, or what are you looking for?
I think, well, mainly what I'm looking for is that um I think like I worry about running it. Worry about the interceptor lifecycle management. That that's what mostly bothers me. It's like that 'cause, like my line of thinking is that it's true, like yeah, we can leave that to the user. Um and so I'm asking myself like what the question of like what if we didn't? So that's mostly what I'm looking for. Like what if we didn't? How would that change our design? And and so that's what led me to think of okay, well, um, if we ran these things locally on the node, your life cycle does change a bit, right? We have like your replication is already predetermined, right? It's the number of nodes that you have in the cluster. It will have in pods. You only have one of these per node, right? So it changes the how it looks. And so that's what and then like there's some other things that change, I think even design. So I wanted to explore that. That's kind of where I'm going with this. I wanted to explore that idea as a different concept, instead of just leaving it entirely to the user and how they want to do it.
I mean, I guess like we could offer like some suggestions how to run it, but I feel like setting some like real constraints like would be limiting to how people want to run it. For example, like some people might want to run it as daemon sets. I would expect like in a case that you need some maybe higher privilege pods that need to like have an access to the node resources and like manage the pods on the node. So that would be one scenario. One scenario is like with the high availability that you do not need so many replicas. If you have a big number of nodes, you might, for example, have only like 3 replicas running for the interceptor in the cluster, and then use like a leader election for that. So like I feel like I know like what you are like want to do, like to have some clear guidance for the users, but I'm just not sure like we should, or like that we should enforce it.
I was wondering about the same question, like what's the real advantage of running this as a daemon set? I can see some use cases where we don't want to do that. Like I know we have a lot of these things that are storing the state of a database application, for example, and synchronizing daemon set pods that are all doing the same thing and not trying to disrupt the same shard of this database would be much more complex than just running one replica or two replicas with leader election, and that's it. So I don't see the great benefit of using daemon sets.
Yeah, I think so the way I'm thinking about it is so the daemon set versus independent life cycle is that the independent life cycle side is kind of what you're getting at, Daniel, is that it sort of matches the application in a sense. Like you can run a few replicas of it. It's probably very specific to the application and whatnot. And the way I'm looking at it is the daemon set approach is like about the node and evicting pods that are local to the node. So it's sort of like a lower level. It's like we're looking at it not so much at an application level, but just saying this daemon set should understand how to evict this pod or these pods on this node. And to my mind, that looks like so that's why I'm thinking about it as a daemon set. So it's a slightly different scope, I guess you could call it. I don't know.
That makes sense. But it's also moving the failure domain to the node, right? Like if the node has some other issues and it can't work properly, like, I don't know, the disk is full or something like this. Also, your daemon set pods that might be responsible for doing the interception will not run anymore or might not run anymore. So you're coupling the life cycle of the interceptor with the pods it's supposed to work on, but you're also coupling the failure domain.
Yeah. Yeah. No, I agree. Yeah, I think so that was kind of like the question I was kind of asking myself, like, is that a good thing? Like, do we want to have the the interceptor that is responsible for evicting pods on the node share the life cycle with the same pods on that node and the node itself?
Yeah, I mean, if it's avoidable, I would expect it to be run somewhere else, because usually when you want to drain the node, you want all the pods gone, so it can be done like as it is, as I said, when it is the highest priority, then you can still run it there. And in some cases, it might make sense. Like, for example, if you need to manage the storage on the node, then for these pods, you might want to run it as a daemon set on the node and be tied to the lifecycle. But I feel like I think like we should give some guidance on that. For example, when we present this feature. But yeah, I think like we need to figure out the API first. So like that's what I'm looking from this point. Like to assess our priorities in that regard.
Yeah, that makes sense. I think for specifically on the API side, like I think what I'd be looking for is like the heartbeat side of it. Like the timeout. Like the question is like when the kubelet is going, or not the kubelet, when we're going to decide if we should move on from this interceptor or not. So what ends up happening in the case that we have it's just a controller with a bunch of replicas. We are going to we're going to let that interceptor, the interceptor will still run and it will do whatever it's doing, and we've timed out its interception and we move on. And so like on the daemon set side, so what becomes of the timeout? So that's where it becomes interesting. Like I'm wondering if we don't use a timeout, we we have some sort of like gRPC call, and we have some way to like check health locally on the node, and we use that as a way to determine if we should skip this thing or not. Like, is the pod actually ready or running? And it's node local, we'll probably have a better time looking at it that way and figuring it out and understanding if it's working. So that's what I was looking for on the API side.
Yeah, I mean, like technically it could make sense, like that you would like have a better knowledge about your interceptors, but practically, like it's like doing like networking like without like the API server is very hard, on Kubernetes, and like hard to do consistently like across like all users or like different like infrastructures, etc. So like it's like easy, for example, for a kubelet to do the probes like on its own pods, but when you don't know like where the interceptor is running, and I don't think like we can make such like a constraint that we should like constrain only as for example Daniel said about the failure domain, to constrain it only to the node when the pod is running. So we don't have like the control where the pods are running. So like the only like access point is like through the API, and uh, that's and that's also why it is hard for us like even today, as like I put like some other topic about the workload aware scheduling. Like even today when we have like some pods that are part of some application, like we don't have the knowledge about the controllers of the pods. I like even though like you have own references, these are usually done like to some API object, but like the for example like the deployment, but even but usually like the deployment like API or some CRDs, like it's impossible to track down the controller. So yeah, I think we don't have like such a feature like today in like Kubernetes in general.
Okay. Yeah, something to think about. I don't know. Something about it to me seems appealing, and maybe even the answer is that we can even think about, maybe it's like, what about both? I mean, we don't constrain, but like maybe there's an architecture for these interceptors that there's like a something running locally and then some sort of um controller that's not running locally. I don't know, like there's something there like that's interesting to me because like I'm thinking about, like, I guess the way I'm thinking about it is that the way the kubelet functions. I'm wondering like if we can use some of that scope, we can leverage some of that scope with something like a daemon set. And then perhaps for other cases more advanced, we also need a controller that manages those daemon sets or something. Yeah, I don't know. Something to think about. Yeah, I'm not sure how that would impact the API, but something, I don't know. There's something I have to think about there.
Yeah, but certainly like you're right, it's like that this is the failure point, like how the interceptors are run. And so yeah, so we are basically offloading this to the users or to their own components to figure this out for themselves. Yeah, if I may continue, like this is one of the points I wanted to discuss. So like today we have like lots of ways how to like what or like different kinds of evictions or like pod disruptions. So for example, you can have like the API initiated eviction, which is done for example during the drain, and then you can have like the like node evictions. For example, when you are kubelet is running out of resources, it can evict the pod, or like we say evict, but it's actually like deleting the pod without any like a gracefulness. And or it can use also the graceful termination seconds. And also during, for example, when you are using the taint, so when your pod is tainted, it can also get some like delay, but then it will be deleted. So when you want to like introduce like a new concept like eviction request, and want to make sure that your application is like terminated gracefully every time, you still have like a lot of these vectors where like disruption can come from, or also the, or for example for the pod preemption. So the pod preemption also can use only delete calls. Like it can like take suggestions from the PDBs, but it can also like you can get your pod deleted. And usually when you are also deleted, the graceful termination seconds might be sufficient in some cases, but in some cases it might not. And usually the pod itself is not, is basically one only has some time to clean up, and it might not be enough to gracefully, for example, migrate the application. So it's in a different state already. So like one of my like things I would like to propose is like also add like eviction request type here. And so basically we should be able to like replace like any evict or delete call like in existence with like eviction request. So if we for example want to remove a pod which is tainted, or the node which is tainted, and the pod does not have like enough tolerations, then we could create the eviction request, and it could also gracefully terminate and be moved from the node. But I think like the type itself could mean that we still would like to like fall back to the original behavior, which is like deleting the pods. So instead of like the fallback, which today would be to call the eviction API, we could have a fallback which would delete the pod. But you would have a way of like intercepting this. Yeah, I acknowledge like this might not be feasible in all cases. For example, when the node is running out of resources, and then if you have all the pods, like, or the eviction request blocking this, then you could it could result in starvation. So this would be like on a case-by-case basis. We would basically have to go through every like kind of eviction and see like if we can replace it with the eviction request, or if we can replace it. Maybe we might even replace the node evictions with some more like some more forceful eviction requests. So basically there would be like a shorter, not just like a heartbeat deadline, but more like a real deadline to basically complete the eviction request. And this also goes for spot VMs. So if you are in the cloud and you run a spot VM, and the cloud provider needs to take this VM back, you basically have only a short amount of time to leave this spot VM, and there might be some graceful termination, but I feel like it's like it should be the user's responsibility to not run like applications, for example, VMs that need long migration times on these spot VMs, because when it gets disrupted, there is no way of like the VM is going away. So we have like different classes or types of these eviction requests, and I think like this it should be represented in the API. Any thoughts on that?
Couldn't this just be done by different sets of interceptors? Like if the no execute taint API is trying to remove pods, it could create a set of interceptors where the fallback is the delete. And if we are, I don't know, doing a normal eviction, we could use the eviction API as the last one. Like this would keep it generic, it's just a different set of things.
Yeah, I think like it's better to be implemented in the eviction request controller, because if you leave this on, for example, the taint controller, then it would need to share this or like bring the implementation, and we have like more places that would like to do this behavior. So I think like it's better for these to just create the eviction request, and then according to the type, we would either like evict or delete at the end. But yeah, like this is like just one suggestions that I will try to propose, and then we will have to go to every component to see like if we can improve like the gracefulness of the termination. For example, it might be hard to implement this for the preemption, and we have to see like what's like the intersection with the pod priorities.
When you said in the beginning that you might want to get rid of all the leads and maybe move it to the new eviction API, do you also mean things like deployments, scaling down replicas?
Yes, I meant that it should be possible to move everything to this, but it like it should be like technically possible, but in some cases it might not be feasible to do. So we should explore it, even for example for the replicas and deployment, if we can do that, or if like it would hinder with the operation of the deployment totally.
Interesting. I'm just asking because we have a team internally that wants exactly this. I need to have a look again what's their problem and what they want to do, but they were searching for something where they can have control about all downscaling, eviction, and everything. So all these kind of requests, and then execute custom code.
Yeah, I guess we could also like bring this on or in like on opt-in basis. So like if you would like to, for example, control the downscaling or something, it could be just by setting some field. Like there is in the cap, there is like an issue opened that also wants this feature in the like the replicas downscaling. So for example, we have the pod deletion cost today, and it's in some cases it's not enough, and yeah, that there might be a way of like adding like different behaviors to the replicas downscaling. But this is like these are all of these are follow-ups. So like we are just like designing the API now and want to see like what should be or what could be possible to do with this. But like which like parts of like the Kubernetes ecosystem actually like use this API or interact with it, and that's to be seen. Yeah, I'm not sure if you want to go into another topic, or like maybe we can skip the last point and yeah, and then leave this for some other time.
So did we cover all of the API changes and points you wanted to talk about in this enhancement then?
Yeah, I think mostly. So yeah, I just wanted to see like what are your first thoughts on all of these? So yeah, like what the next like follow up for me is like to rewrite the cap to basically introduce these new like APIs, like for the interceptor, like for the type, for the requester. Yeah, I wanted to see like what we yeah, I would like to revisit the topic of like the communication bits a bit more, bit between the interceptors and requesters. But I guess like this can be also done as a follow-up to this feature. Okay, so since we have like a couple of minutes left, I will go to the last topic, which I also added there, which is about the workload ever scheduling. So there is this proposal from SIG scheduling, and yeah, just I will put the main slide here. Yeah, yeah. So I saw like they had like they had a discussion in their SIG, and they are basically proposing a new approach for like scheduling or rescheduling of the pods, and it intersects with our proposal as well. So I didn't see like anything concrete yet. So to me, it seems they are just gathering the use cases and basically trying to look at this from a high level approach, as we can see here. And so they are like, I feel they are like trying to define a workload, and yeah, that's so basically they are just stating the problem they want to solve.
Can you explain how it intersects with some of our proposal?
Okay, so like one of the main use cases, I think here has to do with like the sorry, resource reservation and like scheduling and rescheduling. And when you want to reschedule, they are mentioning like you could have like some reservation API, but like one of the first things like when you want to reschedule is like you have to catch the intent. So which is like for example when you drain the node, you want to catch when the pod should be evicted, and this is where we come in. So I don't know like how they would like this like to be all integrated together. I don't think they have like a concrete proposal yet, so I would like to discuss the option of using the eviction request, that it would go basically between the like the workload controller and the scheduling request. Yeah, so like when we look in our cap, we also look at some of the like the rescheduling or descheduling use cases. Yeah, so I feel like they are like trying to cover all the ground from like a high level. Yeah, I just wanted to bring this up. So yeah, I will try to go like visit their meeting maybe next week and try to discuss with them how this all fits together. And yeah, also maybe Ryan, do you want to also introduce the node maintenance cap someday?
Yeah, so I actually have a bunch of that I've written down. Some like a kind of like my take on the approach. So that was my plan. I think I'm thinking like I could do. So I wanted to do like a perspective of like NVIDIA's experience from node lifecycle. I mean, I could do it next meeting, um, and then another one will have to be like the node maintenance cap. So But I don't want to take like 2 straight meetings. So I think what I'll do is I mean I'll post what I have pretty soon. And then we can kind of talk about it offline. And then when we get to it, we can get to it. So we can kind of just start working on it offline, and then we'll bring it up in a meeting on specific topics.
Yeah, that sounds great. Like take as much time as you need. So we are not in a hurry, and I think we can like follow up on the eviction request. We can follow up in the cap reviews. So
Yeah.
we have been doing quite a bit of that. So I will post updates there, and yeah, we can use these meetings for some other presentations, and also to give like a highlight of the cap once you are ready.
Yeah, absolutely. Sounds good.
Cool. Thank you.
Okay. All right. Do we have I think that was the last topic, right? Do we oh, let me go the meeting notes again. Yeah, I think we're okay. Yeah, I think we're all set then. So there's no other topics then. All right, have a good day, everyone. Thanks, everyone.
Bye.
Bye-bye.